Welcome to our channel Learning Math. In this video, we're going to learn about GCD and LCM. GCD means the greatest common divisor and LCM means least common multiple. As you see, GCD we have taken it from the first letters of each word. Also LCM the same. Now let's remember together what are the divisors and the multiples. For example, 3 times 5 equals 15. We say that 3 and 5 are the factors or divisors of 15. Also, we can say that 15 is the multiple of 3 and 5. Multiple means the answer of the product. Well, let's remember together. How many 3 do we add by itself to get 15? Aren't they 5? So if we repeat 3 for 5 times, 3 times 5, we will get 15. Also, if we say how many threes does 15 contain, 15 divided by 3 will give us 5. So 15 is divisible by 3. We say that 3 is a divisor or factor of 15. The same if we think about it, how many 5 do we add to get 15? 3 fives. So if we repeat 5 3 times 5 will give us 15. Also 15 divided by 5 gives us 3, the same. So 3 and 5 are the divisors or factors of 15. Also 15 is the multiple of 3 and 5. Now to understand GCD and LCM, there's something which is very important, the prime numbers. Prime numbers have only two divisors, which are 1 and themselves. Before reading these examples, let's learn them together. For example, 2, it's only 1 times 2 or 2 times 1. We cannot multiply any other numbers to get 2. So how many divisors does it have? As you see, it has two divisors, 1 and 2 itself. So 2 is a prime number. 3, you can write it 1 times 3 or 3 times 1. How many divisors does it have? Only two divisors, 1 and 3 itself. So 3 is also a prime number. What about 4? Isn't it 1 times 4 or 2 times 2? How many divisors does it have? 3. We don't consider 2 because it's repeated. 3 divisors not prime. It should have only 2 divisors to be prime. What about 5? It's 1 times 5, also 2 divisors, it's a prime. 6 is 1 times 6 or 2 times 3, 4 divisors, not a prime. 7 has only 2 divisors, 1 and 7 itself. So we say that 7 is also a prime number. Sure, prime numbers are infinite. We have just explained some examples. The most important thing for you is to memorize that 2, 3, 5 and 7 are prime numbers. Now to find the GCD or LCM, we should learn what we call prime factorization. Here we're going to learn prime factorization by tree method. Let's start by an example. 36 is 6 times 6. Well, also 6 is 2 times 3. We can say that also here 6 is 2 times 3. As you see here, 2 and 3 are prime numbers. We cannot decompose them more. So this is a decomposition into product of a prime factors. That's why we call it a prime factorization. Now let's look at it. How many 2's are we having? Aren't they 2? We say 2 times 2 is 2 to the power 2. Also, how many 3 are we having? We are having 3 times 3. For 2 times we say it's 3 to the power 2. So we can write 36 as 2 square times 3 square. Square means raised to the power 2. Also, if you write it as 9 times 4, it will be the same. Look at it, please. 4 times 9, 4 is 2 times 2. Also, 9 is 3 times 3, the same. We have 2 for 2 times and 3 for 2 times. We say 36 is 2 square times 3 square. So you shouldn't be afraid, but you should write the correct factors of each number. Another example very quickly, 72 is 8 times 9, 8 is 2 times 4, while 9 is 3 times 3. Well, we should check up if there's any number that we should decompose more. As you see here, we have 4, isn't it? 2 times 2, we can decompose it. Now we copy the rest the same. Now just count them. How many 2 are we having? 3. So 2 times 2 times 2 is 2 to the power 3. Also, how many 3 are we having? 2 times we write it 3 to the power 2. So we can say that 72 is 2 to the power 3 times 3 to the power 2. By the same method, we can factorize 45, which is 5 times 9, so it's 5 times 3 square. It doesn't affect if you write it 3 square times 5. In multiplication, you can proceed that. Well, what's the GCD? Here we're going to find their GCD. The greatest common divisor. To find the greatest common divisor, we should choose the common base and the least power. Look at them, please. We have just copied their answers. Why should we choose the least power? We want a divisor, which is common. The number should divide the first and the second one. If you note something, 2 to the power 3 is 2 times 2 times 2 3 times. Also 2 to the power 2 is 2 times 2 for 2 times. Now how many 2's are repeated? As you see, we have repeated it, or it's common for 2 times. We say it's 2 square. That's why we choose the least power. So to find the GCD, we choose the common base with the least power. As you see here, we can write it, the GCD of 36 and 72 is equal to what? Here 2 square, 2 square and 2 cube, we write 2 square. 3 square is repeated, we write it sure for one time. We just calculate them. You know that 2 square is 2 times 2, 4. 3 square is 3 times 3, 9. Now 4 times 9 is 36. Well, by chance, it's 36. I'll insert another video to explain why in some cases we get it in this way. It should not be always the smaller number of them. Well, how to calculate the GCD of all of them, 36, 45 and 72. Here we choose the common base between all of them. As you see, 2 is found in the first number but not in the second, so we should not take it. Here, 5 is not common between all of them, while 3 is common between all of them. We write it with the least power. Here, as you see, in all cases, it's 3 to the power 2. We say that GCD of 36, 45, and 72 is 3 square equal 3 times 3 equal 9. Now, what about the LCM? LCM, least common multiple. Multiple, it should be the greatest one. Multiple is a multiple of the first and the second number, so in this case we choose all bases with the greatest power to get the multiple, the LCM. How to calculate it? We have just solved them. You know that 36 is 2 square times 3 square, 45 is 5 times 3 square, also 72 2 cube times 3 square. To find the LCM, we choose all bases, whatever they are common or not. Well, as you see here, we have 2 square, is found in the first and the last one, but we choose the greatest power. 2, the base 2 is written here. So we can choose 2 as a common base. We choose the greatest power here between 3 and 2. We choose the power 3. Here 5 is not common, but we're talking about LCM, so we can write it. Also 3 square, the base 3. We search if it's common only to choose the greatest power, but as you see here, all the powers are the same, so we write it times 3 square. So the LCM of 36, 45 and 72 is what? As you see, 2 cube, we choose the greatest powers times 5 times the 3 square. Now we just calculate them. So here, 2 cube, we multiply it 3 times by itself. 2 times 2, 4 times 2, 8. Also 3 square is 3 times 3, which is 9. 5, we copy it. Now we just multiply. 8 times 9 is 72 times 5, we copy it. We multiply the first two. Well, 72 times 5 is 360. So this is the LCM. Something important, we can use instead of a tree method prime factorization in this way. For example, we can write 108 is divisible by 2, divided by 2, it gives us 54. We keep on dividing it to get 1. Also here, 54 divided by 2 gives us 27. We can divide it by 3. It will give us 9. 9 by 3, 3. And 3 divided by 3 gives us 1. So we can use prime factorization in this way. If you don't know the rules of divisibility, I will upload another video explaining what are the rules of divisibility. Here we are having another example. To know if it's divisible by 2, we can check up the ones digit. It should be 0, 2, 4, 6, or 8. Well, here as you see, the ones digit is 7, so it's not divisible by 2, but we can check up if it's divisible by 3. 1 plus 4, 5 plus 7, 12, so it's divisible by 3. We just divide them. We will get 49, which is 7 times 7. So divided by 7 gives us 7. Also divided by 7 gives us 7. So you can use any of the two methods in your factorization. If you have large numbers like 9,000, we can write it as 9 times 10 times 10 times 10, as how much zeros are you having. Also, we can decompose 9 into 3 times 3 and each 10 into 2 times 5. Here 15,000, you can say it's 15 times 10 times 10 times 10, or you can say it's 3 times 5 times 10 times 10 times 10. We keep on decomposing it to get prime numbers. So 15 is 3 times 5, 10 is 2 times 5. Now we just write their values, their answers. As you see here, 9,000 is 2 to the power 3 times 3 to the power 2 times 5 to the power 3. Look at them, please. To find the GCD, we choose the common base with the least power. Here they are both 2 to the power 3. We write it. Also, 3 square and 3, we choose the least power, which is here 3. Also, 5 to the power 3 and 5 to the power 4, we choose the smaller power, which is 3. So, it's 5 to the power 3. Now, let's move to the GCD, how to find it. So, we choose the smallest base. The base with the smallest power, sure common base. 2 to the power 3, we have 2 to the power 3, we write it the same. Times 3 square, here we have 3, same base, but we choose the smaller power. Here if it doesn't carry any power, its power will be 1. So between 1 and 2, we choose the power 1. We can write it 3 to the power 1 or 3 the same. Between 5 power 3 and 5 power 4, sure we choose 5 power 3. Now if you know something, if it's difficult for you to calculate, we can say that 2 to the power 3 times 5 to the power 3 is 10 to the power 3. Here is a rule for powers. Pay attention please. If we have the same power between them times, we can directly write it as 2 times 5, which is 10 to the power 3. Now we can copy 3 the same. Here we multiply them times 10 to the power 3, which is 1000. So 3 times 1000 is 3000. Thank you for watching. If you enjoyed this video, please like, share and subscribe.